Hello, class. We are here to go over these exercises to give us a little more practice in R before we move forward with the semester. So the exercise we will go over here, and you notice that we need to use R. So let's open our studio and get started. What we're looking at is RStudio. Maybe I will begin by just removing any saved objects. It is not a bad way to get started. Well, what is my working directory? Because I'm about to create an R script. All right, let's change it. So let's set my working directory. We will go Documents and then our Files. Wonderful. Now let's create an R script. And I will go ahead and save as Extra Practice Module 1. Now we're ready to get started. Maybe I will even begin my script with this command. Wait, you can't see my face? And more importantly, you can't see the worksheet? Well, let me just move some things around. Let's get started. The first question is short answer. Perhaps how I will do this worksheet, I will type all of the commands in my R script and run them along the way. At the very end, I will put all of the answers into a file I can save as a PDF for you and put this in Canvas. Okay, so the short answer question, what is the class of this object? Well, let's define Y. It's a vector. We put in the number 5 and true. What do we know about vectors in R? Well, they have to take in all of the same type. So it looks like I fed in numeric and logical, but you can't do that in a vector in R. So we can just ask R, what is the class of Y? Now let's run this. In fact, what is Y? Well, it's the vector 5, 1. R has sort of forced this logical true to have numeric value 1 so that all of the entries in Y are the same. Well, let's move on to the next one. But perhaps before I do, it's good practice to number the questions because in the end, I'm going to save my R script. And if you were, say, handing this in, you would have the script to turn in. Now, this extra practice worksheet is not to turn in, but you will definitely have assignments. So let's put number 1. And then this was A. And then in between questions, it's not a bad idea to clear the variables. So now I am on B. What do I need in 1B? Well, I want to define X to be the vector 1 to 4, and I want to define Z to be the vector 1 to 2. The question is, what is X plus Z? Now, let's type it. X is a vector of length 4, and Z is a vector of length 2. Hard time adding them up. So let's see what R does, and then we can talk about it. So let's run this. In fact, I will go all the way up to here. We have a vector of length 4, and it's 2, 4, 4, 6. So what's happening here? Well, what will happen is that X has length 4, so it will just cycle through Z again to get something of length 4. In fact, we can see this. So let's take the vector 1 to 4, which is X, and then add this vector 1 to 2, and then we cycle again 1 to 2. You see, this is what it is doing. So it's adding 1, 2, 3, 4 to the vector 1, 2, 1, 2, like this. Letter C, well, this is asking what is returned by this command. This here, matrix multiplication, and C of 1, 2 is a vector. This T is the transpose. Maybe before I run this, let's come down here and just see what happens when I calculate T of 1, 2. Well, this looks like a 1 by 2 matrix. In fact, let's see, the very next module, we will learn this, but you can ask R, is this a matrix? So is matrix. Oh, I need one more parenthesis. And the answer is yes. So on the right, we have a 1 by 2 matrix. And on the left, well, you could also ask, is matrix just this vector? Well, no. So what is R going to do here? We're multiplying a matrix and a vector on one side. Well, naturally, it will make the vector either be a row or a column such that the product will be defined. So now that we've talked a little bit about what R is doing, let's run this. You see, we get a 2 by 2 matrix. Well, this makes sense. If this is 1 by 2, the only way this product is defined is if this is 2 by 1, and the result is this 2 by 2 matrix. Next question, it asks us what happens when we define this nested function in R and we evaluate at 3. So let's write the code that we just see in this worksheet. And then we can ask to evaluate f of 3. Well, if we think for a moment what's happening, f takes in one argument. Inside of that is a function g that takes in 2 arguments. And then we're reporting back this. So if you evaluate f of 3, you will report back 3 plus g of 3, 3, which is 3 plus 3 plus 3 squared, or 6 plus 9, we should get 15. So let's run it and see. Yay! Okay, just as we thought. Wonderful. At this point, this is the end of the short answer. Let me just go ahead and save my R script. Now let's continue. The next question, we have a group of 10 people with different ages. We want to use R for each part of this. Now, we could do this without R, but the whole point of this is to practice with commands in R. Well, if you remember from the module, and I will just paste this, I created this age vector already. Don't have to use this one. You could use any 10 different ages, but my vector has the ages 10 through 15 and 60 through 63. Now, what do we want to do? Well, we want to find the sum of all the ages. Then we want to find the age of the youngest person. Well, we know it based on how we constructed the vector, but we are practicing these functions in R. So that would be min age. We want to find the age of the oldest person. This would be max age. And then, I'm not sure what this means, but we want to find the square root of the age of each person. And this will be a vector. We can just take the square root of the entire vector. All right, so let's run this. What do we have? Well, here's the sum, 321, the minimum 10, which we knew, the maximum 63, and then here's this linked 10 vector in which each entry is the square root of one of the 10 ages. Let's move on. Number 3, we want to use R to calculate the sum where x runs from 1 to 1,000 of x squared. Well, you don't want to type in all of these terms. So let's use a for loop. So for, let's say I am this 1 to 1,000. Well, I want to calculate the sum, but the issue is I don't have a variable yet. So let's back out of my for loop and we can make our sum. Maybe I will call it S sum. Initially, this is going to be 0. Now let's jump back into our for loop. We want sum to be what we had the last time plus x plus I, that's my index, squared. And then we can ask R to report back the sum at the end. Well, let's run it. It's a really big number. How do I know if this is right? Well, probably what I recommend is you don't start with 1,000 even in your for loop. So let's go back to our for loop. We can check for small values by hand. So let's do to 3 and run it like this. We have 14. Now this should be 1 squared plus 2 squared plus 3 squared, which is 9. So you're adding 9, 1, and 4. This is 14. Okay, so far, so good. Let's go ahead one more index. What do we get when we go to 4? 30. Well, I would take 1 squared plus 2 squared plus 3 squared plus 4 squared. The first 3 add to 14. We just calculated that. And then 4 squared is 16. 14 and 16 makes 30. So this looks right. So this, trying it for these small values gives me sanity check. Now we can just go back and put 1,000, which I would not want to try to do mentally or by actually writing it down. All right, I feel slightly more confident that this would be the right answer based on checking for some small values, what my for loop is doing. So let's move on to number 4. Well, we have 3 parts. First, we want to create a vector capital X of length 30, where the kth element is 3 times k. So if we just did this would not be right. Here, the kth element is just k. So let's take 3 times this. And we can ask R to report back. It looks great. We have a vector of length 30, and we can see that the kth element is 3 times k. All right, now let's move on. First of all, we want to create y, 30 elements, but all zeros. So we would do this. We define y. Here we could use rep 0 30 times, and then ask R to report back what's y. So let me just highlight and run this. Third part, we want to reassign the values of y using a for loop. This is the most involved thing we have done, but it is wonderful for us. But it breaks into 2 cases. If k is less than 20, we want to reassign the kth value of y to the sign of 2k. If k is bigger than or equal to 20, we want to assign the kth value of y to this definite integral. Now, let me just, down here in the R part, before I get into coding in my script, let's just practice the integral part because we have this hint about this $ value at the bottom. So we learned about this in this module. We can integrate. Well, square root is already defined in R, so I don't have to define the integrand. I can just type square root. Lower limit is 0. And, well, let's just take the upper limit to be, say, 20. That's the first one we're going to put in our vector. So upper equals 20. If you know about what R is actually doing, this is numerical integration. And so it's an approximation, and it tells you 59.62849 with an error estimate. Now, what happens if I do this $value? Well, it's just reporting back the 59.62849. And so that would be more ideal to put into our vector. Okay, now we can jump into our for loop. So y already exists. It's a vector of all zeros. We want for, let's put this in our script file. In fact, maybe before I do, let's save it. For, we want k in 1 to 30. Well, here's what I was saying. We have to think some because we have two cases. So for this, I can use an if-else. If k is less than 20, we will assign capital Y of k to be sine of 2 times k. Else, well, this is when k is bigger than or equal to 20. We want to reassign and I can just copy down here from where we were practicing and paste. Except I want upper to be k. And then that's the end of our loop. Let's report back vector y. Okay, cross your fingers as we run this to see that we don't have any issues. So I really just need to start here. Well, everything ran, and y is no longer the 0 vector. So how do you know if this is right? Well, one thing we could check, we have already calculated this interval from 0 to 20 of square root t dt. So this should be capital Y of 20. Okay, that looks good, but we could also check the first 19. So let's do the following. We could ask the question. Let's take the first 19 entries of y, and is this equal to, well, if you take sine of 2 times, this should be this vector. And we get yes. So I'm going to say it looks reasonable. The sanity checks I went through checked out. At this point, we've solved all the questions. In fact, our answers are sitting in R. But let's create a PDF file together where we have our answers, so you can keep watching to see how I personally would do that. Thank you. What we're looking at is a Word document, which I will ultimately save as a PDF. So far, what did I do? Well, I copied and pasted my short answer responses for number 1, A, B, C, and this last one should be D. And we have our answers for number 1. So then we can move on. I think starting with number 2, I will go up to the script and copy and paste it. But I also want to include my answers. So here's the script. And then here's what is asked. We can put space here and then go into R and copy and paste the answers. Now, if we were submitting this, so first of all, this is not to submit, not this extra practice worksheet, but when you submit your homework, it's not a bad idea if you are mixing code and actual answers to just highlight your answers. So I will do that here. All right, we can move on to number 3. We can copy the loop. And then we find the answer from R. And then we had one other question, which was number 4. You can also, so you see I'm copying and pasting the code from my extra practice module 1.r, the script. You could also go to where you have saved the script and open it in a text editor, but I still have this open. So let me copy and paste all of this. And then we can just insert the answers. Let's see, this for loop broke across a page, so I will probably just move it all down. Wonderful. Now let's just save this as a PDF. This module 1 answers PDF. I will post this on Canvas for you. I will also post the .r file. Moreover, when you do submit an assignment, you need to submit both things. So more details of that will be in our Canvas course. But this was the end of our discussion of these practice problems. Thank you so much.